to number one, and what are the various options for your open source visualization because of the constraints in the IT budgets? Because from strategy to actions, visualization is the key because you have lots of dashboards, but to take actions real time and quick, because big data is business at the speed of decisions, right? So if you can just
So
highlight that.
the question is, how do you balance between open source and commercial data visualization tools that are there? The space is very, very nascent. It's very unlikely that needs are consolidated, in the sense that it's very rare in our experience that two companies are looking for the same thing. And we are yet to find, for example, one tool that has a reasonably good coverage of the kinds of visualization needs that any organization has. So the short answer is, you would not be picking one tool, step one. Now, step two, what should that tool be? Should it be open source or commercial? I think that largely depends on the intensity of your needs. If you say, look, I'm not too fussed about it, I want something that can draw bar charts, there are a reasonably large number of tools. If you say, no, I want something that can specifically draw a reasonably sophisticated diagram that matches the layout of my power plants because I want to show exactly where the power is failing in this particular region and so on, then you may be left with at most one, maybe two tools, and you may not necessarily know what those are. So you're probably going to settle with the first one because finding the second tool is going to take a good 6 months more. So time may be the bigger constraint than money. So if you're a commercial enterprise, then go for the first tool that meets your needs. I would say that that will be my answer for 2014. Hopefully 2015 it'll change. And as long as you can afford it, well and good. If you can't afford it, then just wait for a year and hope that something comes up.
We have any other opinion? Sanket, will like to add on this? Sanket is, by the way, founder of Blob City, which is a next generation database. So the question was usage of commercial versus open source applications. It was on visualization, but we can generalize it to other areas as well, like analytics or database, which you sell. So you have to keep it closer.
Now?
Yes.
Yeah. So there's very little that you can add, is because open source is also equally good. The commercial ones are also equally good. Each tool has different capabilities, is what I would say. So you really have to choose by what capabilities you want. Most of the commercial tools are more capable than the open source, and that's the reason they are commercial. That's the reason they are selling, right? But I think the biggest advantage by choosing a commercial is the support you get. So for enterprise deployments, you do want the support if something goes wrong, and if it's really critical data and mission critical applications, you should go in with commercial.
Yeah, I mean, many companies are adopting the method that if you do not have a buy-in in terms of huge dollar figure, then you start with open source, do a pilot project, find some kind of a prototype, and then get the investment from the company. So this is what they are doing. So initially they start open source. Once they have to scale up, and when the complexities arises, then of course they have to go commercial. Also, a lot has to do with companies' enterprise architecture principles. So there are two ways. So if a company decides to go open source, it's all right. But there are companies who will not like to take any open source technology. So they will not adopt any open source. If you are working in those companies, and if you want to adopt, suggest an open source technology, then you have to be mindful of your company's enterprise architecture principles. So be aware of what will get accepted, and accordingly you can pitch in the right kind of solution if you are passionate to start a big data project or suggest a big data project in your company. So Sanket, we'll have the next question from your table.
Okay, so I got more than 10, 12 questions here, but I think we can't
No,
cover all of
I
them.
think you have seen how we have been doing. So first question you ask, and then in the second or third itinerary, all the questions will get answered. So you can ask the question which has not been answered.
Yeah, I'll ask the ones which are probably not going to be covered in the conference.
Mm-hmm.
Okay, so the question is, there are actually two parts. One is, I like to combine two questions. Okay, first is a more general one, which is big data is a hype, right? When it is no good without analytics. Is that correct? So does big data have any value without analytics? And if it doesn't have value without analytics, should analytics be the hype and not big data? And one more thing I would like to mention is another important thing that came up is data cleansing. Okay, what are the processes and steps or tools available to clean data that's coming?
I'll just take a crack. I'll go to Parag as well. See, hype is created from the technology, of course, because it is very difficult to sell that technology otherwise. Analytics is pretty easier to sell because it directly gives return in terms of business. So hype gets created by the technology. But big data is, according to me, 20% technology, 40% analytics, and the rest is visualization, narratives. A lot is there on analytics because unless you know what your consumer wants, which analytics can give, and I'm referring to the video as well, the role that technology has played vis-a-vis analytics, vis-a-vis visualization, vis-a-vis the connectivity, networking. So you can just take that example. I'll go to Parag and ask him to share his views.
Sure. So I'm obviously a big proponent of analytics. I won't have to answer that question. But the one thing I would advise is, it's very difficult to define what is analytics, right? I'll use an example. Like I said, Dell.com has been a website much before 2006 happened and before Hadoop happened, right? And as an organization, we have been storing all the clicks, okay? And you guys will see some of this in the presentation. I mean, we get 1 billion users a year on our websites, right? As a result of which, storing all the clicks of every user, and I'm talking about unique users, 1 billion, okay, is huge amount of data. Now, we have used filtering techniques that decide what out of that click stream data do we save. We do not, even as a hardware company, have the ability of storing 10 years of clicks, right? As a result of which, what do we store out of that in itself is, how do I get information from the noise is what you must have heard about, is very, very critical, right? So one is just even what information do you store becomes a science, right? The second piece of it is what do you do with the information you have stored, right? And the sad part of that story is as we evolve, as technology evolves, and this is coming from a technology company, right? As that technology evolves, we guys are realizing that, damn, we wish we had stored all that data from those previous years where we didn't, right? Because now we are able to do a lot more with that clickstream data than was possible for us to even think about maybe 8-10 years ago, right? As a result of which, that again is a science, which is once you have filtered out what out of the noise you're going to save, what do you do with it? And that piece, tying that into, for example, the analytics that create solutions, and then tying that into the visualization, all these 4 pieces combined in my mind bring to you a big data solution. So I don't know if I answered the question in terms of what you had brought up, but I'll let someone else address it as well.
I have one more addition to make here in terms of what you store, right? The other question was how do you achieve perpetual storage? Like for example, you have videos, you have Twitter feeds, Facebook posts. Now they are always alive, right? You will never have a YouTube video go missing. It's data that's only created, never deleted. So how is this achieved? Perpetual storage.
I'll have to defer to someone else. I have no idea how to answer. That's okay. Yes.
Typically, yeah, the data is keep growing. The volume of data continuously increasing. That's the total challenge of huge amount of storage required to store. But at the same time, the IT government and CEOs are being to define their discipline and practices to retention of the data. What data is really required for future use? What is the data they need to keep it? What the data
So we have this next question. Now we are moving to the how part. How exactly to do this project, big data project. So I have a question. I'm from three. So we have a question from Sabyasachi Upadhyay from EMC. As a data scientist, can you tell me what kind of modeling techniques do you use in the industry arena for analytics? Do you use sophisticated methods like SVM? Related to that, this is on analytics. Is it a software, like is big data a software that you install and you start working on it? Is it like Java, C++? Is it like, can you frame it like another programming language? Is Hadoop similar to that? And how to identify big data source providers, analytics, how do you find out? So we'll start with the first analytics one. If you can, you pick the mic to answer. Okay. Right. So the first question is, as a data scientist, what kind of modeling do you use? Would you like to address that, Anand?
Issue with big data is that take a simple average is a reasonably complex task. You've got to spread across one distribution and so on. So honestly, 99% of the answer is just hammer numbers.
Any other add-on? Yes.
One of the person that asked the question was, can someone create a hype or can someone mislead the people using a big data?
No, I think this has been answered in the previous section. Whether it is hype or whether it's a myth, some of the videos shows some of the projects. Okay, right.
And hey, my sales has roughly remained flat. Whereas if this way my competitor says, I put the axis to 83 and say huge bar, 87, almost 30% decrease, 86, 85, 84 is almost zero. And my competitor sales is dramatically declined. By just moving the axis up and down, I can do this. I can choose the right metric to present myself in a appropriate way. And this is not new. How to lie with statistics is something that's ancient. I don't think that big data has changed the equation. If anything, it's making it even more easier because you can go back and say, oh, you can't do that calculation, only I can because I have big data, you don't.
Sure. Yes, Parag, you would like to add?
Add to that, very good example. The one thing that comes to my mind is something that I learned as I was learning my statistics in grad school was statistics doesn't lie, statisticians do. Okay? As a result of which, you really have to be very careful. Really have to be very careful how you present the data. Garbage in, garbage out. All our data folks here will realize that. Right? And the black box example that Anand used. All of us are guilty of using statistical black boxes or technology black boxes. Even in a large corporation. campaigns, and we say, hey, this is the output they gave us, and go and test mechanisms to use the example, figure out if it is really giving us more value, right? So I think it's very, very critical that when we do use black boxes, you have very strong processes to ensure that you are seeing the value and it's not garbage in, garbage out.
Yes, so now we are coming to the final 5 minutes of panel discussion. Would like to devote it on questions related to technology. So if we have any questions, I have a bunch of questions on technology. Do we have anything from your table, Sampath? On technology, yeah.
So one question here from Deepak is, will NoSQL replace or coexist with RDBMS? I'll give my very brief take on it, but would invite the others to add on to it, please. So my view is that they certainly will coexist. I mean, ultimately, if you take what's known as the CAP theorem, which says that of the three things that you can provide, consistency, accessibility, availability, and partition tolerance, which means that you either have a system that is consistent, in other words, what data you put in stays correct roughly, availability, it's 100% available, and partition tolerance, it's available across multiple machines. The theorem says that you can have only 2 out of these 3. And a relational database effectively takes a choice that I will be consistent and I will be partition tolerant, that is, I'll be available across multiple machines, but I won't be 100% available. So which means that if I make an update in one machine, then while it replicates into all of the other machines, you can't make another update, it may not necessarily be available for reading and so on. NoSQL makes a different choice. It says I will be consistent eventually, but in the meantime, I will make sure that it's available 100% and I can work across distributed systems. There are other choices that other systems can make. And these are effectively 2 different choices. If you want, let's say, a logging mechanism, you want it to be 100% available. I just keep dumping the logs. It doesn't matter if one system says that I have 17 million visitors and another says I have 17.0003 million visitors. It's okay. As long as eventually I get to the right answer, it's fine. Whereas with relational databases, if I say, have I made a transaction and has there been a 5,000 rupee debit in my account? You want a yes or a no. You don't want it, oh yeah, approximately. So maybe you made it, maybe you didn't, I'll tell you in a few minutes kind of a thing. Right? So I guess the systems will coexist.
Right. Sanket, will you like to add? We have 1 minute, if you can. And yes. Right. So we have last question on the technology side. About 30% of the audience are working on big data projects. And the question was that how do you start a big data project? What are the technology used? So I will go to the audience who are actually working on big data projects, maybe a raise of hand, who will just in a 1 minute share their experience, maybe 2 or 3 experiences from the delegate. Would like to know. Anyone who would like to share their experience in big data projects, how they can start? Or should we leave it to the expert panel? I did see, okay. Yeah, 30, yes. If you can introduce yourself, the company, and and then answer this, please.
Hi, my name is Iman. I'm working for a from Apple Market. I'm a part of India sales So when we started this music, so initially the first was process structured notes and assembly structured data. So we started off with installing the components there.
I'll just interrupt in between for the benefits of those. How much time did it take to install? How easy was it to install Hadoop cluster?
So when we started in January, there was very less documentation available, but now the documentation is there and it takes around
Okay.
So, you installed components like Zoom and CSS MapReduce and MongoDB, HBase. So, what we did was like we got the logs, real-time logs, because you on the server. So, you were pushing those logs on real-time basis to our HDFS.
So Fluent was the tool to push the logs.
So, which actually collects the data from the server and everything. It sort of creates a channel between your source and your destination. So as soon as your data is generated, you can simply push that data into HDFS and run your mapping program and talk. Second thing which we used was Apache Flip. That is a tool which basically used for parallel processing, and in that we wrote something scripts which were converted into automatic map use programs and which were run on that RAG data and sort of made that into a structured form to store into HDFS and MongoDB. Then after that we sort of used Tableau and other visualization tools to show that data in a very predictable manner for dashboards. So the reason why we use this is because we wanted to identify the compliance issues in law. Like what are the users which are trying to access restricted URLs?
So the project status, which is currently, was that it was envisaged in the beginning, or there was challenges and things didn't work.
Challenges, a lot of challenges in deciding what technology to use and how to go about it. But I think it's not that difficult because there are a lot of tools now in the market which simplifies the process. And now we have a full-fledged environment where we are pushing the logs to the server, processing the analysis, and then showing them on the dashboard.
Excellent.
That is now very
So when did the system become stable? When from experimentation phase till the time it became stable, how much time? What was the?
This is not a very, you just explore everything that you need, and
Okay.
this was a very basic thing which we could have done. So we reached the completion, and we had two demos, and so the dashboards were pretty impressive because you're using Tableau and ClickView for that.
Right.
So that was.
Thanks. So we'll just summarize. Important thing is companies are now creating center of excellence on big data. So you had center of excellence being created on software testing, on analytics. So on big data itself, center of excellence needs to be created. And finding the technology is not tough. They're open source and commercial, both are available. In fact, the commercial vendors also give free trial version, so you can download it. 45, 30 minutes, 1 hour. In 2 days, your big data infrastructure is ready. Right from storage to analytics and to visualization, and then you take a case study. Important thing is from where to get the data source. So that is the toughest part, and then how to use it. So that's where the little amount of time is required. Once you crack it, you are ready, and then you can scale it up in different verticals for different business reasons. On this note, we finish this panel discussion. Thanks to all the participants for sharing, asking the questions, and for speakers, to making it interactive. I hope you like this kind of panel discussion, which actually addresses the question that the audience have rather than what the organizers set up. So we have the next session by S. Anand. He's a chief data scientist from Gramener. His topic is visualizing big data. To introduce Anand, he's a chief data scientist and a co-founder of Gramener. And Gramener is a data analytics and visualization company. He has devised and designed IT systems for organizations such as Citigroup, Honda, ICICI, IBM, Oracle, Tesco, SAP, RBS, etc. Anand has an MBA from IIM Bangalore and a BTech from IIT Madras. He has worked at IBM, Lehman Brothers, Boston Consultancy Group, and Infosys Consulting. He blogs at s-anand.net. So we have Anand for you. Yeah.
When I said most analysis can be done just using averages, this will be a presentation that almost exclusively uses averages. I'm going to be talking about what kinds of insights and stories you can tell out of big data, especially when you visualize the data, and I'm going to be purely talking about case studies. The first one that I'm going to be talking about started with the Education Department of Tamil Nadu, who had a question. Look, can we predict students' marks? Can we figure out if, based on their demographic characteristics, based on their gender, their community, their age, whatever, can we take a good shot at how like what marks they're likely to get. We said, look, before you do that, let's just start looking at the distribution of marks. For example, how many students score what marks in English? This, for example, apologies for those at the back who can't see it at the bottom. This is a distribution of marks in English. So the number of students that scored 0 marks, 1 mark, 2 marks, 3 marks, all the way up to 50 and 100 and so on. And you can see that it's roughly a normal curve, right? There are very few students who score 100%, there are very few students who score 0%, and it's roughly in the middle, but there is a spike. You know what the spike is, right? Exactly, the pass mark, right? So which means that there are a lot of students who ought to have failed, but the teachers are just gently pushing them up, which explains the dip around the 33 and 34 and the spike at 35. But it's not happening consistently because there still are students flunking at 34, which means that there are some English teachers who say, no, I shall not give you a pass mark no matter what you do. Right? So at least in English, there's room for prayer early in the morning, right? If you're a borderline student, you want your paper to be corrected by the right teacher. Whereas in social sciences, looks like the teachers have all ganged up together and decided that nobody shall flunk between 30 and 35. There's a full gap out there. And between 27 and 30, there is some room for discretion. Here I will use my judgment to decide whether I will pass these students or not. The exception are 3 students. You won't be able to see them at the back, but there are 3 students, exactly 3 students who flunked at 31, 32, and 33. I don't know what they did, but barring these 3. Now the education department is worried because there is no diktat from the education department that this is how you will be grading the students. The teachers have gotten together and decided that in Tamil Nadu, this is how we shall grade it. The mathematics teachers have done a similar thing. They have also decided that between 30 and 35, no one shall fail, except for, again, 3 students. I don't know if it's the same 3 students. But what is interesting is that the spike out here is pretty huge. Actually, it's a little larger than this. I chopped it off for consistency with the previous graph. It goes on for about 2.5 times and it'll hit the ceiling. So in mathematics, there's this much of moderation, but despite that, there are more students flunking in mathematics as a single subject than in any other subject. 60% of the single subject failures are happening in mathematics. The other weird thing is that there are a lot of students scoring exactly 100%. There's a spike at 100%, which is, I've heard a lot of theories about this. I don't know what the right answer is. Some people say that, look, mathematics is one of those subjects where you can actually score 100%. It is objective, and therefore there is a clear measure that you have, in fact, score 100%. Another, and this is the view that I personally subscribe to, another view is that mathematics is one of those few subjects that exhibits what's a naturally bimodal distribution. What's a bimodal distribution? Well, consider an exam that is taken by 4th standard students and 10th standard students together. You'll find all of the